Alright,
So
welcome
welcome
to
to
the
the
second
second
part
part
of
of
this
this
chapter
chapter
number
number
5.
5.
So,
So
in
in
the
the
last
last
video,
video,
I
I
have
have
shown
shown
to
to
you
you
about
about
one
one
example
example
for
for
the
the
application
application
or
or
the
the
usage
usage
of
of
the
the
parameter
parameter
rule
rule
for a
for a
simple
simple
or
or
direct
direct
question.
question.
And
And
now
now
we
we
moving
moving
on
on
for
for
the
the
second
second
part
part
in
in
the
the
subtopic,
subtopic,
which
which
is
is
we
we
have
have
still
still
in
in
the
the
part
part
of for
for
us
us
to
to
guide
guide
the
the
approximation
approximation
for
for
the
the
area
area
under
under
the
the
graph,
graph,
which
which
is
is
the
the
Simpson's
Simpson's
rule.
rule.
Right.
So
So before
before
that,
that,
I
I
want
want
to
to
highlight
highlight
something.
something.
So
So
let's
let's
say
say
in the
in the
question
question
they
they
use
use
the
the
terms
terms
of
of
subinterval
subinterval
or
or
tricks.
tricks.
So
So
direct
direct
take
take
that the
that the
number
number
given
given
as
as
the
the
n.
n.
Meanwhile,
Meanwhile,
if
if
the
the
question
question
use
use
term
term
of
of
ordinates,
ordinates,
ordinates is
is
a
a
point.
point,
Let's
let's
say
say
8,
8.
and
And
then
then
our
our
n
n
is
is
we
we
have
have
to
to
minus
minus
1
1
from
from
the
the
value
value
used.
used.
For example
For
here,
example here,
in
in
this
this
approximation,
approximation,
we
we
have
have
7
7
subinterval.
subinterval.
1,
1,
2,
2,
3,
3,
4,
4,
5,
5,
6,
6,
7.
7.
And
And
also
also
can
can
be
be
referred
referred
as
as
the
the
8
8
ordinates.
ordinates.
8 ordinates. So
So
we
we
have
have
1
1
point,
point,
2
2
point,
point,
3,
3,
4,
4,
5,
5,
6,
6,
7,
7,
8.
8.
Or
Or
in
in
other
other
words,
words,
I
I
can
can
say
say
also
also
we
we
have
have
y
y
naught,
naught,
first point, y1,
y1,
second
second
point,
point,
y2, third
third
point,
point,
y3,
y3,
fourth
fourth
point,
point,
and so on and so forth until we have y7, which is the 8th point. Alright, so again, if we have the question, use the word ordinates. Okay, ordinates. For example here, ordinates. So our n actually is n equal to 8. We have to minus 1 from the given value. Alright? Okay, good. So now we move on to the Simpson's rule. Okay. Okay, so Simpson's rule works very well for on a curve. Meanwhile, for stability rule works better for a linear function. Alright? And then comparing to the Simpson and the stability rule, Simpson use a function of quadratics as our approximation. For in this diagram, you can see here that we can approximate that the area of the black curve, okay, the area of the black curve is slightly equal with the curve of this red quadratic line or px. Okay, so we have equalized or approximate the black curve again, fx, with the one shape of quadratic function here, px. Alright? Okay, so that's the idea. Alright. So if I use one approximation, means that I use one function of quadratics, one quadratics, px. So we will have 2n. And number 1 and number 2, so 2n. If I approximate again, we approximate two quadratic curves. We have the purple px and the green px. So here we will have 4n. So one approximation will give us 2n, and two approximation will give us 4n, and so on, so forth. And thus we can say that n must always even number. So starting from 2, 4, 6, 8, 10, and so on. Okay? That's only applicable for Simpson's rule. Okay, so next slide. So don't worry, we still have formula. So the step is just like the same from the table of the rule, but the difference is just the formula. So in the formula we have three parts again. So we have h over 3, h is the width, also same given by b minus a over n. We have the summation of y0 plus yn plus 4 multiplied with the sum of the odds value. We have y1, y3, y5 and so on, only the odds number, and plus with 2 times the sum of the even even value, y2, y4, y6, y8 and so on and so forth. And this term is our last term in the expression. So that's with yn minus 2. So remember, for this Simpson, n must be always an even number. Okay, cannot odd number. Alright. Okay, so from the last method of trapezium, we will draw this kind of table. We have x column and 2 column for y, but for Simpson's rule, we will extend the column of y become 3 columns. Okay, later I will tell you why we have to do or to draw at least 3 columns for Simpson's rule. And the first column of y is for the starting and the ending part of the y, like y not until yn, and the second column is for the odd number of the y, and the last column is for our even number of y, y2, y4, y8, 6 and so on and so forth. Okay. Right, so let us do some example here. So I will use this example here in this key. Example number 3. Okay, so example 3. So evaluate the integral from 0 to 2 of 1 over sec x plus 1 dx using Simpson's rule with n6. Give your answer correct to 6 decimal places. Alright, so we take back the step in the last video. Okay. So we just use the same step, but the formula is slightly different. So we need to modify or make use with the Simpson's formula, but the idea is same, just change the formula. So from the first step 1 for Simpson's rule, okay, we need to identify a, b and n. So n is our interval, which is 6 in integration. So a is our lower limit 0, and our b is our upper limit is 2. Alright. And then from these 3 we can calculate value of h. So h is given by b minus a again divided by n. So just replace the values of b with 2 minus 0 over 6. We have answer 1 over 3. Alright. So we have done finding h. Next, before we move on, step number 2, we need to identify the y or the fx. So fx or y is what are being used inside the integration. So now we have 1 over sec x plus 1. Okay, so we have done step 1, moving on. Step 2, we need to write back all the value inside the equation of Simpson's rule. So we take back our equation of Simpson. Okay, so we have the equation of Simpson here. So step number 2 is write back by replacing the n with inside the formula of Simpson. So here in this example we have n is 6. So we just replace with 6, 6 and 6. And we have the equation h over 3 big bracket summation between y0 plus y6 for n plus 4 times y1 odd number, y1, y3 and until y5. How do we know y5? Because if we replace n with 6, we have 6 minus 1 will give us answer 5. So we will stop at 5 for the odd number, or the odd part of the equation. Next, we move on for the second, the last one, 2 times y2 and just with y4. So how I know until y4? So when you replace n again with 6, we get 6 minus 2 will result with 4, and thus we just only add up y2 and y4 only, no y6. Okay, so now we have done step number 2, writing back the equation of Simpson with the given n. Alright. Now we go for step number 3 is we need to we have to create table of value for the Simpson's equation. So now we need to we must have at least 4 columns, 3 columns for y, 1 column for x. Okay. So x okay, so we have 3 columns for y. Right, so here is our x and we have y is our function, which is in this case we have y equal to 1 over set x plus 1, 1 over set x plus 1. Okay, so we need to find value for x naught. In order to get value for y0, x1 for y1, x2 for y2, x3 for y3, x4 for y4, x5 for y5, and last one x6 for y6. So we will stop at 6 because we have we just have n. Okay, we have n is equal to 4, 6. So we need to stop at 6. Okay. Alright, so same as stability rule. So to get x0 always start with an a. So here a is equal to 0, so we have to start with 0. Okay, and then to find x1 we have to plus with h. So 0 plus h is 1 over 3 equal to 1 over 3. Okay, and x2 we need to find until x6. x2, x3, x4, x5 and x6. Okay, so for each one, just plus h. Okay, just plus h for each one. Okay, so plus with 1/3, you get 2/3. Then we have 1 for xc1, plus h again, we get 4/3. Again 5/3, and the last one get 2. Okay, so to check our answer correct or not, we just check with the last one, x6 must be always equal to b, right? Okay, so now correct. So now we want to find y value. So remember, this column only for the starting and the ending part of y. So in this case, we have y naught and just with y6 starting and ending. And this column of y belongs to the odd number, which is y1, y3, and y5. And the last column here belongs to the even number of y. We have y2 and y4. Okay, we are done. Okay, so we just substitute all x with the equation. So again, I use a shortcut. So just copy the equation. Plus 1, calculate 0 for x0 to get y0. So we get 1. Next, calculate for 1/3 for y1. We get answer 0.8 0.86603. Okay, remember, always use more than 4 decimal point, no less than 4. Always more than 4. Okay, continue for the next part. We find for calculate for the y2. So 2/3. Okay, equal. So I get 0.774559. So we have 0.77460, and continue again for y number 3. So calculate 1 equal to, we get 0.70711, 0.70711. Continue until y6. So 4/3, 65465, 0.6546.5, and then continue until y6. Okay, so we have done finding y with the respective x, and next we have to find the summation for each column. So the first column we have answer 1.57735. Okay. Second column will give us answer of 0.8.86603 plus 0.70711 plus with 0.61237 equal with 2.18551. So 2.18551, and the last column 0.77460 plus 0.65465. Okay, so we have 1.42925. 1.42925.
Okay, good.
Alright, so the three columns actually is for the three parts of equation. So this part is the value for this part, okay, yellow part, and the pink one for the odd number, and the green part is for the even number of summation of 1. Okay, so we have done set number 3, and the last one we have to insert the value from the table back to our equation of Simpsons. Okay, so last one, step number 4. So H is 1/3 in bracket over 3. Right? So big bracket for the yellow part 1.57735 plus with 4 from the formula of the pink value 2.18551 plus with 2 of the green or for the even number 1.42925. 2925. Okay, close bracket, bracket close. Okay, so now we can calculate all the value. So just use the calculator. So we have bracket of 1 over 3, bracket of 3. So bracket of 1.57735 plus 4 times 2.18551 bracket plus 2 times 1.52925 for 1.425 bracket again. Okay, so make sure all bracket has the partner. So equal. So we have the answer is 1.46421. 1.46421. Okay. Alright, so we have done, but always check the last request. So we have to put the answer with the 4 decimal point. Therefore, so we have to write our equation, our answer as 1.4642 as the last answer. Alright, so we have done one example for Simpsons using the march direct equation of this example. Okay, and please try on your own to solve the approximation using Simpson with different ends. Alright, I think that's all for this example. That's quite right. Just same as the result, but just use a different formula. and we have the third column for y for the odd and even number. Alright, so see you on the last part of the chapter. Okay, so have a good day, night. Have a good day, bye.